Hello. System involving the compound formation with incongruent melting point phase diagram of sodium chloride water. In this type, two components react with each other and give a new compound as like congruent magnesium zinc, but this compound starts to decompose before its melting point and give a new solution. For example, copper sulfate 5s2 system. This dissociation reaction or equilibrium called per eutectic temperature. Phase diagram of sodium chloride water. This system. This is a system with incongruent melting point. Sodium chloride reacts with water to produce sodium chloride. Water which is not stable up to melting point and starts decomposing above 0.1 degrees Celsius according to the equation. Ice plus solution, ice plus sodium chloride water, sodium chloride water plus solution, and solution sodium chloride. This area is the solution only, this area ice plus solution, this area is the ice, sodium chloride water, solution sodium chloride, and solution sodium chloride water. I have drawn A, B, C, and D point for the explanation. A, B, C, D. At this point, B is the eutectic point. This area is the ice plus saturated solution. This is saturated. Ice axis, sodium chloride. Water axis. This area is the 100% sodium chloride, and this area is the 100% water. Saturated solution, sodium chloride solid. Sodium chloride, water solid plus saturated solution. In the above diagram, point A represents the freezing point of water, 0 degrees Celsius at 1 atmospheric pressure. When sodium chloride is added to it, the freezing point curve of water along the curve AB, ice is in equilibrium with solution. Applying the reduced phase rule, F equal to C minus P plus 1 equal to 1, so that AB is univariant at point B, temperature is minus 21.2 and 23% sodium chloride. A new solid phase dihydride sodium chloride 2S2 begins to appear. Hence, sodium chloride water and ice becomes equilibrium. F equal to C minus P plus 1 equal to 2 minus 3 plus 1 equal to 0. So, system at B is non-variant. Point B is known as eutic point. The system consists of solid ice and solid sodium chloride water only. On further addition of sodium chloride, freezing point rises along the curve B.C. or B.C. The point C corresponds to 0.15 degrees Celsius. In this curve BC, sodium chloride water and solution are equilibrium, which is called solubility curve of sodium chloride. So F equal to C minus P plus 1 equal to 1. The system is univariant. Temperature is 0.15 degrees Celsius. At point C, poreutic change, noting the phase intermediate between a solid and liquid that results from the melting point of solid occurs. The solid sodium chloride 2S2 is no longer stable above 0.15 degrees Celsius and changes into anhydrous sodium chloride solution, sodium chloride S2O, sodium chloride anhydrous solid plus solution. Above 0.15 degrees Celsius, sodium chloride water is changed into anhydrous sodium chloride plus solution. At point A represent the freezing point of water 0 degrees Celsius at 1 atmospheric pressure. When sodium chloride added to it, the freezing point curve is of water along the curve AB. Ice is equilibrium with solution. System at B is non-variant. Point B is eutic point. At point B, temperature is 21.2 degrees Celsius and 23% sodium chloride, sorry, minus 21.2, 23% sodium chloride, a new solid phase dihydride becomes to appear. Point B, minus 21.12 degrees Celsius. Appeared sodium chloride water. On further addition, sodium chloride freezing point rises along the curve B.C. The point C is the temperature, and 0.15 degrees Celsius. Sodium chloride water in solution curve equilibrium is called solubility curve of sodium chloride. At point C, eutectic changes. Of course, the sodium chloride water is no longer stable above 0.1 degrees Celsius and changes into anhydrous solid chloride. Okay, it's all about phase diagram of sodium chloride water system. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now. Bye bye. See you again.